We're live. Perfect. All right. So 6.1 solution and electrolytes is what we're going to be talking about. There we go. Okay, it's not too bad. All right, so yesterday we did a little introduction on solubility. So just another little word for you. Hydration is just the term of what it means. You don't necessarily need to write all this stuff down. It's just this whole process of dissolving that the solvent is the thing that does the dissolving. The solute is what gets dissolved, is that they need to break their own attraction within themselves, and then they need to form new attractions to the other thing in order for it to be dissolved. A much more simplified process that I would potentially have written down in my notes is that this is what needs to happen in order for something to dissolve. So the intermolecular force between the solvent, so using this picture as an example, the salt, the sodium and chlorine ions need to have their attraction to each other broken. The attraction between the water molecules that they have for themselves need to be broken. And then a new intermolecular force, new attraction needs to happen between the water and the salt. And so it's very much like, breaking up with someone and dating someone else. First, you got to sever your own relationship, and then you got to form a new relationship with somebody else. And if those things don't happen, then things don't dissolve, right? If you can't separate your own attraction to whoever it is you're dating because the new person, maybe they're not nice, or they're not good looking enough, or they're not caring enough, or they're not tall enough for you superficial people out there, then the attraction to the new person is not going to be enough for you to sever the attraction between who you're already with. And so that's kind of what this entire game is about when it comes to dissolving. It's about attraction. And things will always move to whatever they are attracted to the most. That's the entire process of dissolving. And that's kind of what I'm saying right here, is that if the strength of the intermolecular force, if the attraction is just not the same or stronger, then things just won't dissolve, period. So this is just a little animation of it. You don't need to write any of this down or draw any of this down. In the video simulation that you're going to be watching later today will be a good representation of this. But it's just kind of what's showing you what's going on. So here we have water is polar, right? We can see in the diagram that we have those. Those are going to be attracted to the negative and positive charges of the ionic compound. And so what happens is the attraction between the water molecule and that negative ion is stronger than what water has between itself. And so that's why the water sticks to it and is able to be carried away. And when this process happens over and over and over again, just ion by ion, they get carried away until they are separated into individual ions that are now what we call free floating ions. They're able to move around the solution as opposed to being locked into place like they were with a solid. So to summarize all of this, this is what I would write down to dissolving ionic compounds, is when an ionic compound dissolves, the ions are separated from each other and they form free floating ions. And that's kind of the key, that that negative charge, that positive charge is not locked into that crystal anymore. It's able to move around. And that's really important when we talk about electrolytes here in a little bit, because if we can have a charge, a negative charge moving around, that's what we call electricity. And so these ionic compounds dissolving and the ions becoming freed is what allows them to conduct electricity, right? This is why you should never be in a bathtub and throw a toaster in, because you will electrocute yourself, because there are free-floating ions in there. There are charges that are able to move from point A to point B, and that is what we call electricity. So electrolytes are just substances, solutes, things that when they dissolve, they create charges. And as a result, electrolytes conduct electricity, and typically they are ionic in nature. This is why, Gatorade, Powerade, all of those energy drinks, this is part of their marketing, is electrolytes are important. After you work out, after you sweat, have you ever tasted your sweat before and it's really, really salty? You're losing electrolytes, and you need electrolytes in your body because your entire nervous system works by conducting electricity. It's electric impulses that make your muscles twitch, like your heart or your arm or your quads or anything like that. And so if you don't have these things in your body that allow electricity to be conducted, well, then you're dead, and that's no good. Covalent compounds are a little bit different in nature. So here we can look at sugar, for example, which is a polar molecule. It has those positive and negative charges. And likewise, the water is going to be attracted to those because opposites attract, and that's always true. So it's the exact same process. Water sticks to it. That attraction between the water and the sugar is stronger than the sugar is to itself, or the water is to itself, and as a result, it's able to be carried away. But what we don't get are free floating ions, because that positive and negative within the sugar molecule, they stay together, right? With ionic, the positive charge could go off to the right, the negative charge could go off to the left. They were free floating. They didn't need to hang around. But because this is covalent, because these atoms have to stay together, because they're sharing electrons, they have to stay together in order to stay positive. And so that positive and negative charges stay together. With ionic, remember, it's a transfer. I gave you an electron. I'm stable now on my own. You're stable now on your own. That's why they can separate. But with covalent compounds, again, because they're sharing, they have to stay together in order to stay stable. So what you don't get, it's the exact same process, but what you don't get are free floating ions when polar molecules dissolve. So I'll give you a minute to write this down. Or if you're watching the video, you can just pause. These are what we call non-electrolytes. And these are typically covalent molecules when they dissolve. And they are non-electrolytes because they do not produce free-floating ions. And as a result, they do not conduct electricity. So typically, what you're going to be asked on the quiz is, here's a compound. Is it an electrolyte or is it a non-electrolyte? And basically what you're looking for, is it ionic or is it a covalent molecule? Is it a metal and a non-metal, or is it two non-metals? That's kind of what you're doing throughout this. So here is a table. It's kind of a scale. So we have electrolytes and non-electrolytes. And again, there is a copy of these notes, not just a video, a copy of the PowerPoint if you want to reference this stuff while we're doing it. So here we have kind of a summary of electrolytes and non-electrolytes, you know, everything we've done before. Non-electrolytes, covalent compounds. The molecules move away, they dissolve, but ions are not formed and therefore don't conduct electricity. But with electrolytes, we have a scale. Both electrolytes are ionic compounds, but the amount of free-floating ions determines how much electricity you can conduct, right? If you think about electricity just in nature, a big honkin' thick wire, think of like what's on the wire that's coming into your house or the electrical wires that are outside. They are huge, fat wires. That's a big open highway for tons of electrons to just move through. But if you think about the wires in your house, they're really tiny. So it's a bottleneck. Think it's, you know, it's a highway versus, you know, a neighborhood street. Not as much volume can pass through. And so it's similar here with strong and weak electrolytes, that the amount of electricity that you can conduct depends upon the amount of ions you have in water. And so if you have things that dissolve really well and make a ton of ions, well, those are going to conduct electricity really well. If you have things that kind of dissolve, and because of that, they only kind of make a few ions, they will conduct electricity, but just not as well. Okay. Now, one of the things that you're going to have to do is what we call dissociation. And this is basically just writing the chemical equation of the process of an ionic compound dissolving. It's really not that hard. So you'll be given a substance. You're probably going to need your pink sheets again. These little ion charts that I'm showing to the camera right now. So let me just kind of walk you through examples of what you're going to have to do. So imagine this is the quiz. I give you this first compound, KNO3, and you have to determine, is it an electrolyte or is it a non-electrolyte? And hopefully by looking at it, you recognize, oh, potassium is a metal. NO3 is a polyatomic ion. So that's going to be ionic, that's going to be an electrolyte. And what you then have to do is, all right, well, show me how KNO3, potassium nitrate, breaks up to make ions. So what you're going to do is you're going to look on your pink sheet, you're going to find potassium, and you're going to find nitrate, and you're just going to write the compound into their respective ions. So K has a +1 charge, and NO3, nitrate, has a -1 charge. Again, I'm looking all of these up on the pink sheet that you got at the beginning. If you lost your pink sheet, you can go into the first folder in Schoology and download another one. If we look at the next one, again, it's ionic, calcium is a metal, nitrate, NO3, polyatomic ion, so it's ionic, it's an electrolyte. So how do we write it so that it breaks up into their corresponding ions? Well, I know it's going to be calcium and nitrate, so calcium is +2, nitrate's -1. But in the formula, because of those parentheses, I have 2 nitrates. And so that's going to translate into that coefficient of 2 that you see in front of the NO3. That's what we mean by balance the ions. So I still have the same number of ions before and after, right? The atoms that I start with are going to equal the atoms that I end with. And then if we look at the last one, with sodium and CO3, which is carbonate. So we're looking on our pink sheet. So sodium is +1, carbonate is -2, but again, I have 2 sodiums, so I need to have a coefficient of 2 in front of the sodium, and this is what it looks like. So that's kind of the whole process of one of the things that you're going to be asked to do on the quiz. You know, is looking at a substance, is an electrolyte, is it a non-electrolyte? And if it is an electrolyte, do the dissociation part of it. And I think there's a couple more slides. None of this stuff, you don't need to write any of this down. I don't really even want to talk about it. If you're curious as to what it says, then you can go to the video or just look at the PowerPoint on Schoology and look at those. And then this is the last thing that I'm going to have up here is just types of solutions. Unsaturated, saturated, and supersaturated. This is just as we are dissolving, it goes to a scale. You know, I remember I used to always put sugar in my cereal. And it didn't, as a kid, it didn't matter what cereal I was eating. Whether it was Cheerios, Corn Flakes, Frosted Flakes, Lucky Charms, I didn't care. If my parents weren't looking, I would be pouring sugar in. And it would always make my cereal sweeter, which was always the point. But at the end, I would always drink the milk, which is absolutely the best part of eating cereal. And there would be this milk sugar sludge at the bottom of the bowl that I would then eat because I needed sugar. And that's kind of what happens, right? As we dissolve things, it starts out as unsaturated, meaning that you can put more things in. But then there gets a point where you can no longer, the more sugar I put in, it's not going to make it sweeter because no more sugar is going to dissolve. And then we have this rare situation of supersaturated. This is a rare kind of thing. This doesn't really happen by mistake. You kind of have to be intentional about this. But this is a situation where you have more dissolved than what you would normally have. If any of you are fans of sweet tea, this is an example of a supersaturated solution. So they take tea at a high temperature because the molecules are moving around really, really fast, and you can dissolve a lot at a high temperature, and then they cool it back down. And so you're able to dissolve more than you normally can.